whereas the X3 gives you a lot more hang time and can handle a lot more wind, but its initial pop off the water for the beginner isn't that good. You need to be an experienced rider and have good timing to get the kind of hang time that's possible with the X3. Whereas with the Boxer, you might get 1 second less hang time, but it's very easy to get there because the kite reacts so quickly. It makes the Boxer a really good kite for wave riding too, because it handles so fast and the amount of D-power that you get out of it. There's a lot of parameters, believe it or not, and for example here's the parameters for one kite. We've got the center of effort of the kite, which determines the tow point position of the kite. So basically right here, if this was extended down, that would be the center of effort of the kite, and that's the balance point. From there we can determine where the tow point positions are, the front and the back, and that determines how fast the kite turns and also how much D-power there's going to be. From there we start to look at the profiles, and the profiles for sure determine the performance of the kite. And here you can see this is the profile with the bladder and everything overlaid, the final result. So here's the real profile view. And this is showing the curvature of the profile and the high and low pressure over the surface. So I can use this to help me design different profiles. Here's the leading edge and the whole profile. Now this here is the profile of the kite. This is the wing shape of the kite. That's it at the center strut. That's the profile being used in the center strut. So if we look at the station flow, and we can see here that we have a different profile at different places on the kite. So there's different profiles. And from there, we can look at the station, or the different types of profiles. So for example, here is the profile at the center, and then here's the profile in the middle, and here's the profile at the tip. Okay. These are the different profiles being used. And then if we want to look at all of these profiles at once, we can. Okay. Yeah. So now we got all three profiles on here, and we can change the colors to view different ways. The unique thing about this program is the control that we have. We have just an incredible amount of control of how we work within the program. And we also simulate a wind tunnel. So here we're doing a simulation now, wind tunnel simulation, and computer generated, and here we can analyze our profiles and how they relate to each other, each of the profiles. Basically I send a file to China and I get it back in 5 days, and I usually send about 5 files every time. I mean, here you can see all the pieces that make up the kite. So if we zoom in, you can see here's the new X4 layout, and here's all the individual panels that make it up.
So this is what goes to the factory in China?
This goes to factory. I just email it, and they get the same file, and then it's cut on the plotter, and they build the kite. We have a huge workforce over there, so for us to build the kite here would take 4 days. Over there it takes 6 hours, complete with printing and everything. So these are the main canopy panels. Mm-hmm. And then over here we've got the leading edge pieces. And you can see there's a lot of detail goes into these pieces. Here you've got the lines that align the struts to the leading edge. You've got the canopy sew lines. You've got little marker lines here that show how everything lines up. Mm-hmm. Everything is automatic within the program. The parameters, I can adjust all parameters very quickly. So for example, aspect ratio, wingspan, profiles, where the webbings go. You know, here you can see even the detail of where the webbing gets sewn on.
Oh, yeah.
And I can change that detail.
That's the toe position, right?
Yeah, toe point position.
Toe point, yeah.
So I'll change it to 7. So now you can see the entire kite changed with an aspect ratio of 7.
So if you put it down to like 3 and 3 or so, can you do that?
Yeah.
Just so we see the changes?
Mm-hmm. So that was 7, and here's 3. There.
Oh, yeah.
So you can see the radical change.
Yeah.
For me, the way I'm calculating is I'm taking the maximum profile depth related to the span. So that's the real way to do it. That's basically the line that runs from here at the max span camber, runs around.
Okay.
Yeah, and then that's related to the span and depth and area.
Yeah.
So here you can see this is has an aspect ratio of 6.75. And here we can change it to just 6.5, and you'll see the difference right away. What we were talking about of a 5 is actually pretty similar to what we're doing now. We still have a similar aspect ratio from the AR5. That's how we were measuring it at the time. We were measuring it a different way, because now we're measuring the maximum camber. Before we were just measuring the width versus the height was giving us the aspect ratio. Now we're measuring the maximum camber versus the area, which is the maximum camber of the foil. So the maximum camber of this foil is somewhere right about here.